Okay, today it's time for the chain rule. And for me, this is the most useful of the basic special rules. So of the product, the quotient, and the chain rule, this is the one that I found myself using the most often. Right, so here we've got a function of a function. Well, I'm going to write it out using the f of x notation, and then we're going to explain what it means. So if we've got f of g of x, and we're wanting to differentiate that, so let's call that h of x. All right. So that means that h dash of x equals f dash of x, f dash of g of x times g dash of x. Now that doesn't look particularly sensible yet, but it's going to. You'll get this one. It's actually not that difficult once we go through it a couple of times. All right. So what does that mean? Well, let's say we had an equation like this. Let's say we had h of x equals 3x squared minus 2 cubed. Right, now we could solve this by breaking it down into parts and multiplying it out and expanding it, and it would take a long time and it would be a bit of a pain. What we're going to do here is a lot nicer and easier. All right, so what we're going to do first of all is figure out what the two parts of it are. So I'm going to define f of x as this, 3x cubed. And then I'm going to define g of x as x squared minus 2. Right, so I've got that down. And the reason that is because what I'm doing to this, f of x is what I'm doing to x, is I'm multiplying by 3 and then cubing it. But instead of looking at x, I'm looking at x squared minus 2. So that's where this comes from. Right, so if we differentiate each of these, f dash of x is going to be 9x squared. And g dash of x is going to be 2x. Let's make that a little bigger so we can see that. Okay, so our rule is that h dash of x, so h dash of x equals, well, first of all, f dash of g. So 9 lots of x squared minus 2 squared times g dash of x, 2x. So altogether that's going to be 18x times x squared minus 2 squared. Now we could expand that, but that's a fine answer there. All right, let's have a look at another example. Let's say y equals the square root of 8x minus 3. All right, so what we've got to do here, that means y is, we could write it out like this. Y equals 8x minus 3 to the power of a half. So the first thing that we do is we're going to deal with that to get a dy over dx. We've got to first of all deal with the half. We should probably be doing this in blue to keep consistent. dy over dx equals 1/2 8x minus 3 to the power of negative 1/2. Right. Then we have to deal with the 8x minus 3, so we differentiate that to get us an 8. Now it's just a case of simplifying that. Well, the 8 over a half is going to become 4. 8 over 2 is going to become 4 over the square root of 8x minus 3. Here's another example. F of x two lots of 3 x minus 2 to the power of 5. Now this would be a real pain to expand it, to be able to factor it, to be able to differentiate it, but watch how easy it's going to be with the chain rule. So f dash of x equals, well, we do the first part first, the 2x to the power of 5. It's going to be 2 lots of, sorry, it's not 2, it's going to be 10 lots of 3x minus 2 to the power of 4, and then times, differentiate that, times 3. So that equals 30 3x minus 2 to the power of 4. Now you see that as a lot more elegant solution than expanding it, differentiating it, and then trying to factorize it. We can do it all in 2 lines. Now sometimes the way this is written is using the dy over dx notation. It talks about a it talks about a u or a something else. So if we talk about y equals 3 lots of x squared minus 4 to the power of 3, then what we can do is we can call it this. We can say u equals x squared minus 4 and y equals 3u cubed. Right. So what we can then find is we find this, du over dx. And that equals 2x. dy over du equals 9u squared. And so to find dy over dx, well, that's going to be this. If we go dy over du times du over dx, we can cross out the du's. Right? So we just end up cancelled to get dy over dx. So what we're going to get is we're going to get this, dy over dx equals dy over du, which is 9u squared, times du over dx, which is 2x. But then we have to go back to our original definition of what u is, and u is x squared minus 4. And so we become this. So dy over dx equals 18x times x squared minus 4. It's exactly the same thing, it's just a different way of writing it. I thought it was good to show you that so that you have an understanding of the different ways that this rule works. Okay, let's have a look at some questions. Question 1. Differentiate this, please. F of x equals 4 lots of x minus 3 squared. 2, f of x equals eight times x plus 3, x plus 3, start that again, sorry, x plus 3 over x minus 1 squared. And number 3, f of x equals the cubed root of x plus 3 over x squared minus 1. Some of these are going to take a little bit longer. You might have to look back over a couple of the previous rules. But have a go at it, and I'll see you in class.